Welcome all, welcome to this lecture of Object-Oriented Programming 1. And in this session, we'll be continuing with Unit 1 and we may also start with Unit 2. That is, we may finish Unit 1 and then start Unit 2. Okay, so let me show the disclaimer, then we'll start. Okay, so let's start the session now. So, see, there are basically, if we talk about softwares in with respect to computer, then there are three types of software. That is system software, application software, and also the utility software. Okay, and uh, if we consider hardware, then in hardware, basically there are CPU and main memories, then there are storage devices, input devices, output devices, and communication devices, right? So now, and if you consider the programming languages, then there are high level languages, there are assembly level languages, or we even call as middle level languages, and low level languages also. Okay, and if we talk about popular high level languages, then there are, these were some of the previously popular languages like Ada and Basic. Then C and C++ became popular, and then COBOL and Fortran were previously popular, and now the C Sharp and lots of other languages have come, and Java and Python and those all have become popular nowadays. And we'll be focusing on Java language, which is kind of object-oriented language. Now we have already seen what kind of specifications are available in Java, what kind of APIs are available, what is JDK and what is JRE, that we have seen, right? What is a Java language specification? It's a technical definition of Java programming language syntax and semantics. So see, these two words you have to remember, that these two words are very, very much important whenever you are learning any particular language. You have to learn two things. You have to learn the syntax, that is how to use the constructs of that particular language, and you have to learn the semantics, that is the meaning of each and everything, and how to form logic and all using that language constructs. Okay. Now, what is an API? API is nothing but an application programming interface, or application program interface. API is basically nothing but a collection of programs, or also called as library, which contains predefined classes and interfaces for developing the Java programs. Okay, so you might have seen in our lab session, we would have used the java.util scanner class, right? So the scanner class is basically available in java.util package, right? So what is this package? This package is called as an API, utility API. This package represents the utility API. Okay, so in the way, there are lots of additions also of Java. One is standard edition that we will be working with, that basically deals with client-side programming only. But when you go further, in further semesters, you will learn about Java Enterprise Editions also, which deals with server-side programming. Okay, and there are other editions also like Java ME for mobile devices and all. Okay. We have already seen what is JDK. It is a development toolkit. It consists of a set of programs, and it can be invoked from command line, and it is basically used for developing and testing Java programs. Okay, and which command did we use for this? We used Java C command out of it. Okay, Java C command, which was available to compile a program, right? Then and also Java command to run the program, right? Then we saw what is an IDE. IDE is an integrated development environment, right? Where we can perform various things like basically like editing, okay? Then you can do compiling of the program. You can build the whole application, okay? You can debug the program step by step, line by line, and there's online help available. These all things are integrated into a single graphical user interface. So that's why it's called as integrated development environment. Okay, NetBeans, Eclipse, IntelliJ, IDEA, Visual Code, lots of there are there. VS Code and lots of there are there, right? We started with a simple Java program. Then we also saw how to compile it and run it. We saw how to compile a Java program using Java C. And then we also saw how to run the Java program, that is uh, Java and the class name. Now, then we saw what is bytecode, right? We saw that once the Java program is compiled, it generates the Java bytecode. Okay, and it has got just-in-time compiler, which makes it much faster now. Okay, so the source code, basically, we know that source code of Java file is compiled and it is generated into class file, which is nothing but a bytecode, and then it is interpreted by JVM, which gives you the output, that is the result. Okay. Then we also saw that there are three types of comments: single line comment, block comment or multi-line comments, and documentation comments. Okay. This Java doc comments start with slash and double star, and this can be extracted to an HTML file. Okay, is the best part of it. Then we also saw, okay, now there is something that you need to take care. Why all this we need to know about comments and all these things? Because we need to make sure that we follow a proper programming style, and also you make use of documentation. Why is documentation needed? So that anyone else or even ourselves, whenever we see our old programs or anyone else sees our programs, then they might be able to understand the program by the help of this documentation or comments. Okay, so documentation is very much needed in order to, nowadays lots of software also and hardware also come with documentation of how to use it, how to troubleshoot it, and those kind of documentations are available in most of the products. It might be software product or hardware product, right? So how do you achieve that kind of documentation part? One is either you use the comments properly, right? And second is you also follow proper indentation and spacing. Now, what is indentation? Say, indentation is something like this. If you have a program which has got multiple if statements, like for example, if true, or let's say if a is greater than 5, then we say something else if a is greater than, sorry, let's say a is less than 5, then you do something. Now, so here we are indenting the program in this way, and then here you say else if a is equal to 5, then you do something, and then you say else you do something. So this is called as, okay, now this else part, see, this else part will basically come, okay, it will this, because if this if starts from here, so the code will start from here, and then here the else part will come, and here the, okay. So you see, this program is typically what it is, typically aligned, it is indented. This program is called as indented program. You can see the steps are being followed, right? So this program is very easy to read and also understand. This program is very easy to read and also understand. You see, this thing, this giving this step kind of thing is called as program indentation, and appropriate spacing should also be given. So for example, here if you write the, check this out, if you write this expression like this, 3 into 3 plus 4 into 4, it's better to give some spaces in between, right? It's better to give some spaces so that the whole expression is readable. You see, okay, it's and the spaces are not this does not affect the processing also. So a single space should be added on every side of a binary operator, especially if you are considering a binary operator, right? Then you should basically use space on both the sides. And second thing is the block style should be like next line style or end of line style. So block style is like something like this, that whenever you start a block, so for example, if you are starting the class ABC, suppose this is ABC class, then you either start it like this and you end it like this, or it is something like you start it from here and then you end it over here. It's something like that, right? So the block can be block style is also very much important. Okay, then comes errors. Now we have to understand the programming errors before you actually start programming, because see, you should be able to know what kind of error has come. You should be able to recognize the error. That is the main thing, right? So there are different types of errors. There can be a syntax error, there can be a runtime error, there can be logical errors. Okay, so the syntax errors basically are the common errors, so, which happen because Java is a case sensitive language. So because of that, the errors might come, right? For example, if you, instead of writing if, you try to write capital F, then this will give you an error, right? Understand? Similarly, if you are using keyword as class, and instead of that you try to use class or CLAS double S, that is capital letters, class in capital letters, all capital, then this will give you error. You see, it will not even compile. So these kind of errors are called as syntax error. So you should be, if syntax errors are there, then mostly your program will not compile at all properly, right? Second thing is runtime errors. Runtime errors basically are errors like divide by zero kind of errors, which due to which the exceptions get generated. What gets generated? Due to this, basically the exceptions get generated. Okay, so if you try to divide any number by zero, it will generate an exception called divide arithmetic exception, which gives the result as divide by zero error, right? So this type of errors needs to be handled using try catch. Okay, that we'll see later. And then if you see, there are some other errors also, like logical errors. Logical errors, basically this logical errors depend on things like this. Say for example, if you are trying to divide 5 by 9, now what is this? We had discussed this thing last time in our session also, that if we say this 5 divided by 9, so here this 5 is what? This is an integer number, right? This is an integer literal. And this 9 is also an integer literal. So what happens? Whatever division takes place, the result is nothing but an integer result. So it will not have decimal point inside it. Not have decimal point inside it. So what we need to make is either make 5 double number or number with decimal point, or make this 9 with a decimal point. You see, so these are kind of called as logical errors. Okay, so there are three types of errors. Either you make the error in syntax, which will not let your program compile properly. Either you generate a runtime error, that is, it generates a runtime exception, which will not let your program run properly. And logical errors, which are not which allow your program to run properly but do not give you the output as expected. Okay, so these are some of the kinds of errors that you people have to make sure that you people don't make these errors, and also if you make it, then you resolve those errors that you have to learn, right? Okay, now just a minute, let me again. Okay. Okay, so then let's consider some examples, like write a program which calculates area of circle. So what do we need to do over here, right? Here we need to in this particular program, for this particular program, we need to read the radius of the circle, then compute the area using the formula, and then we need to display the result, right? So see, check this out. This is the example. Here we will be reading the input from the console from the user. Okay. So here also check this out. Here also we are saying that import java.util.scanner. Right? What is import? Import imports it brings in various classes or interfaces that we want to use. Okay, from various APIs. Right? In C language we used to do what? In C language you used to do hash include, right? Instead of that, here we will be using import. Okay. Then if this is the class, then in this class we have a main method where we will be using system.in and putting that system.in, that is nothing but the input stream, into the scanner object. Okay, by saying new scanner and inside bracket pending system.in. What is the system.in? This is nothing but the input stream object. What is that? This is the input stream object. Okay, and this input stream object refers to what? This input stream object basically refers to the standard input device. So what is the standard input device? Normally in mostly all the PC or laptops, it is the keyboard, right? So directly you are using, through the scanner object input, you are directly using the keyboard. Okay, so you'll be getting the input from the keyboard when you say system.in. It may be different also. You may even provide a different stream, like you may even provide a file stream. Okay, so this scanner object will be used to read the radius from the user. So what do we say? We say we print a message. We say system.out.print. So we don't use print ln because we directly want to get the number over here in this place. So that's why we don't say print ln. We use print, and we say enter a number for radius, and then in the next line what we are saying, check this out. In the next line itself, we are saying input.next double. We are declaring a variable also and also assigning it some value. So now see what happens over here. See, this is the first time that you people will be seeing that this thing you might not have seen in C language or C++. In Java, here you will be seeing that you are declaring the variable over here and getting the input from the user and also assigning that value to the variable. All these three operations happen in a single line. Let's see, what is this? The left hand side is nothing but declaration, variable declaration. Right hand side is reading input from the user, and then what happens? The assignment operator is there, which means the assignment operation happens. So these three operations happens. One is the declaration, one is getting the input, and then the assignment. Okay, all these three will happen in a single line. So what happens is when the JVM sees that you are saying input.next double, it means you want to read a double type of data from the user. So if the user enters something like this, then it is take this thing. Obviously, when user enters is a string, but is converted into a double value, and then it is assigned to this radius variable. Now you can make use of this radius variable. Okay, now you can make use of this radius variable properly by saying radius and that is pi r square, that is the formula to compute the area, and then you display that the area of the circle of the radius, this is the radius, is area. Now here see how you concate it. Check this out. This is a very interesting thing. This much part is your string. What is it? It's your string. Okay. Then comes variable. So this radius variable gets concatenated with your string. This becomes one string. Okay. Then what happens? Then there is this another string in double quotes. So that again will become one string. Okay. And then there is this variable. So this third string and this variable, this becomes one more string. So that is the final string. Okay, that is the final string. Okay. So that is basically what? That is basically so that was the program to calculate the area of the circle. In the similar manner, you can calculate area of various shapes. So now reading the numbers from keyboard, reading the input from the console or from the user, you can use for reading these all methods. Next byte will read you a byte type of data. Next short will read you a short type of data. Next int, which we make use of many times, will be able to use or read a integer data type number. Next long is there, next float is there, next double is there. For each and every data type, there is a next xxx. These methods are called as what kind of methods? Next xxx. What is this x? This x represents the data type. This x represents the data type. Okay. So you can see over here that after next there is the data type name. You see that? Yes. So these methods are basically used to read the input, get the input from the keyboard. Okay. Then we had also seen identifiers and variables, right? We saw various naming conventions or identifiers, right? Then we also saw that okay, one more thing, remember these three are keywords. Okay, you have to remember these three are keywords, so cannot be used as identifier names or variable names or any other class names of that. These are literals actually. True, false, and null. Null represents nothing. Okay, null represents nothing. Okay, not even the garbage value. Okay, then now there are some assignment statements and assignment expressions. Okay, so remember assignment is very much important. In this previous example, you might have seen that in this line, the assignment is happening. What is happening? An object is being created and that is getting assigned to a reference variable. What is a reference variable? That we'll see later on, okay, when we will start learning classes and objects. Just remember this is a type of reference variable, okay. And this radius is a primitive type of variable because the data type is primitive data type, okay. So here an object is being created, here input is being read and is being assigned, here an expression is being calculated or operated upon, expression is executed and the result is assigned to a primitive data type variable. Okay, so assignment operator is very much important. Make sure you make use of assignment operator properly. Okay, and you make use of expressions also properly. Expressions contains variables, values and operators. Okay, So see, this is an expression. What is this? This is an expression. Which one? This one. This is an expression. We cannot say this is an expression or this is an expression. No, these are not the expressions. This is a valid expression. Okay, understand? Okay, let's go ahead and see constants. For constants, we have seen that we use a final keyword. This is how we declare it. See, make sure you declare the constants properly. And what is the what is the naming convention of defining constant? That constants are basically defined in uppercase letters. So how do you define it? You say final keyword. Obviously, you use smaller lowercase letters only because Java is case sensitive. Then the data type of which you want to define the variable or constant. Then the constant name and the value that you want to give it. So say for example, if you want to declare pi as a constant, so how do you declare? We say final double pi, that's pi is equal to 3.141. Okay. Now this p and I are both capital, right? Okay. For example, if you want to declare a string constant, then how will you do that? You will simply say final string color is equal to red. So how do you define color? Obviously in capital letter. Color is equal to red. Why did you define it in capital letter? Why did you define it in capital letter? Why is this identifier given as capital letter? Because it is a constant. Okay, it's a constant. So constant should be declared using full capital letters for whole name. Okay, because it represents a permanent value that is never changing. Then we saw naming conventions. Now naming conventions, you have to remember these naming conventions we have not seen in our video slide. So please make sure you follow this naming conventions also. Okay, why do we need to follow naming conventions? In order to make your programs easy to read and avoid errors. Okay, it becomes very easy for anyone to read your program if you have followed the naming conventions properly. Okay, so naming conventions are basically to be followed when you want to name variables, when you want to name methods and classes. Okay, so make sure for variables and methods you always use lowercase letters. Okay, these are some of the major things you have to remember. For variables and methods, okay, you use lowercase letters. For class name, you capitalize the first letter of the name. Okay, for constant, you capitalized every letter, and you can even use underscore between the words for constants. Okay, so if you are declaring a class, then make the first letter as the capital. Okay, not all the letters, but the first letter as the capital. Similarly, if you are defining a method, suppose here you are defining a method or a variable inside this ABC, let's say int ab, small ab. So now this is a variable. Okay. And then similarly, if you are defining a method, right, then that is also declared using what? Small case letters. Okay. And if you are defining a constant, okay, then you use what? Capital letters that we just saw right before, right? Okay. So see, variables and method names are using lowercase, but yes, camel case is also followed if your name is big or has multiple multiple words inside it, then camel case should be followed. For example, check this out. This is a class called as person. Now person may have first name. So here I declare the variable called first and name, right? So you check this out. This variable is starting with small case letter. But when it goes to a different name, when the second word is coming, see first and name logically are separate words. Although here we are making it as a single variable name, but logically these are two are separate words, right? So first starts with small case letter in order to show that it's a variable, okay, or maybe a method name. And then if a new word comes, you uh, use capital letter to differentiate it. You can even declare it like this. You can say string first underscore name, but it's better to use this naming convention, camel case. This naming convention is called as camel case. Why? Because for each word you just make it capital, so it makes a kind of hump which is similar to camel. So that's why it is called as camel case naming convention. Okay. 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 Any doubt in naming conventions or anything? Yes. Any other doubts? Please let me know. Are you clear? What are the naming conventions? When are these to be followed? Yes. You have to strictly follow the naming conventions when you make your Java programs, okay? And people evaluate your coding skills through your programs itself. Make sure that whenever you are doing programming in teams, people do evaluate your programming skills by looking at your program and your programming style, okay? So naming conventions and indentation and all these things are very, very much necessary in order to uh, in order to make sure that you do good programming and it is recognized also, okay? Okay, so now let's see data types. We have seen data types and operators, right? But now I had not shown you this part, so let me show you that part. That see, these are the 8 primitive data types: byte, short, int, long. Then comes float, double, char, and boolean. These are 8 primitive data types, and these are the sizes in bits that you should remember. So byte is having 8 bits and the range is -128 to +127. And similarly, short is having 16 bits. So basically, if you are talking about bytes, if you are talking about the range in bytes, then this byte is basically nothing but what? It is nothing but 1 byte. Similarly, you have short, which is of 2 bytes. Then integer in Java is about of what is this about of 4 bytes. Then if you talk about long, then it is of about 8 bytes. Okay. Similarly, float and integer are equivalent. They are of 4 bytes. Float is of 4 bytes. Double is having 8 bytes. Character is having 2 bytes, and boolean only 1 bit, not even a byte, only 1 bit, okay, which represents value either 0 or 1 inside it. But Java does not allow you to assign value 0 or 1. It allows you to assign literals, true or false, okay. 1 and 0 are not allowed. So see, these are the size in bytes and these are the size in bits, okay. So see, an integer variable in Java is almost double the size of C programming language, right? In C programming language, normally the integer is of what? 2 bytes, that is of 16 bits, right? So this is the range of short, -32768 to +32767, and this is the range of integer. Similarly, the range of long is there, which is quite long. Then there is a range of float, there is a range of double, and yes, make sure in Java the characters which are of 16 bits, that is about 2 bytes. So the characters that Java supports are up to 65535, or if you add 0 again to it, so the total number of characters becomes 65536. 65,536 characters are supported by Java. So basically, since Java characters are 16-bit, this is nothing but this is called as Unicode. Java supports the Unicode characters, which are 16 bits. And Unicode characters are used to represent most of the spoken languages of the written languages of the world. Like it can also represent the Devanagari script of India. It can also represent the Chinese and Japanese language scripts. Okay, so all those particular characters that are used in those languages can be used by the Java language characters, since the Java supports Unicode characters which are 16-bit. Okay, that's the best part of Java. Okay, so that was numeric data types and operations. Okay, we had seen these types earlier, but we had not seen its sizes. So specifically, that's why I have showed you the sizes today. Okay, please do remember this thing. Okay, now we have seen so how character data type is defined. We know that character defined data type is basically defined like this: char ch equal to a. This is how we define the character. And characters supports both Unicode and ASCII character. That's the best part. Okay. So basically, what happens is Java supports Unicode characters, which is an encoding scheme to support the what with the interchange and processing and display of the written text in the world's diverse languages. So most of the world's languages are supported because of this Unicode character size that Java supports. Okay. So if you take a C language word, that character, that will be of 8 byte, but if you take a Java character, Java language character, it will be of 16 bytes. Okay, so that encoding is a 16 byte encoding. So therefore, Unicode standard has been extended to allow up to basically now 6553 6 characters are not enough to represent all the characters in the world. So Unicode standard also allows up to this many characters inside it. Okay, so which go beyond the original 16-bit limit. These are called as basically the supplementary characters. But in this limit, many characters come in this particular limit. Okay, in this Unicode limit. Understand? So, and if you see escape sequence and escape characters, special characters, you might remember we had used a special character like \n. We have already used which one? \n to do make a line feed or a new line, right? Then there can be \b for backspace, \p for tab, \f for form feed, \r for carriage return. Now, what is carriage return? See, in some platforms, \n just gives you a new line, does not take your cursor back. So, for example, if you return something like this, and now if you do \n, so what happens is your cursor basically comes over here. Okay, where does it come? Comes over at this location. It comes over here. It comes. The cursor comes over here. Okay. Now, actually, this is not a good thing. Your line should start from this location. Over here, it should start, right? So that cursor, taking the cursor basically back from this location to this location is done by this carriage return character. Okay, so that returns your cursor to that particular location, start of the line. Okay, so in some platforms you have to use both backslash n. Along with that, you have to use backslash r also. But in most of the latest platforms, you don't need backslash r. Backslash n is enough. Okay. And if you want to use directly display the backslash itself, then you use backslash. Okay. And if you want to display double quotes, then you use backslash double quotes. So for example, if you want to give the output as double quotes ABC, this should be your output. So how you use it in println? You would use it like this. In println, you would use something like this: system dot out dot println. Obviously, in println, we need to write the double quotes to start the string. But now we want to print the double quote itself, and so if you use this like this ABC, so what will give this happen? This will give you error, because here the string is starting and here automatically ends. And if the string ends, then what is this thing? This is an error part, right? So what we have to do is basically we have to write it like this: system dot out dot println double quotes. It starts the string. Then if you want to use double quote as to be printed, then use a backslash double quote. Okay, so this will escape the meaning of double quote and we'll use it literally as it is. And then we say ABC, and you say again backslash and double quote. Okay, and then you end the double quote over here. So see here what happens. Here basically the string basically is your string of this println, the string that is to be printed. It starts from here and it ends over here. This is the start of the string and this is the end of the string. Okay, and in between that you have, these are the escape characters. Backslash is the escape character that uses double quote as it is literally to be printed, and the same thing happens over here. So that's why you get, from this you get to have this particular kind of output, and the double quotes are also printed onto the console. Okay, so I hope you understand how we will be using special characters. Okay, which are the special characters? About 7 special characters are there. One is for backspace, one is for tab, then a line feed or new line is there, form feed is there, carriage return is there, to use backslash literally and to use double quote literally there are. Okay, and these are the Unicode values. We don't need to worry about it and decimal values, right? We just need to remember that what is the escape character that we use. Okay. Okay, so that was about special characters. Now we have seen casting and all those things, right? We have also seen what is typecasting and what is automatic conversion, right? So see, this thing is what? This thing is explicit typecasting. You are converting what? You are converting a double value. We know that a number having decimal point in Java represents by default a double literal. It is a double literal. That what is a literal? Literal means whatever the value is as it is, that's its value. So if you are seeing a number, let's say 65, then that is the value that it is 65. But if you are saying this, there's a ch. What is this ch? It might have any value, right? That value may change. That's why it is called as variable. It's its value may vary anytime. That's why it is called as variable. Whereas this thing is called as literal. These numbers and all these things are called as literals because the value that it shows is the actual value that it has. Okay. मतलब जो दिख रहा है वही है. It's like that. You are seeing 65.25 and that's the actual value. But here you are seeing CH, it might have different value. If you are assigning 65, then it's 65. If you increment it, it will get incremented. So CH has got different value other than what it is seen. CH is seen as CH, but it will be storing some value inside the memory location, okay, for which it has been named. So that's why it is called as variable. This thing is called as variable. This thing is called as literal. So see here we have got a float literal. So what do? We convert it into char. So this will assign what? This will assign basically the number 65. And since the 65 is in the range of the character, we just now saw that the range of the character is what? Range of the character is, check this out, range of the characters are 0 to 65535. See, negative numbers are not allowed in characters. See that? 0 to 65535. So obviously this 65 is a valid number as per character range. Okay. And when you display it, print it out, it prints it as a character A. Okay. Now you can even do something like this. Character can be cast into numeric type by saying A, the single quote inside, in single quote you use A, you cast it into int and then assign it to a variable I, which is integer type. And if you print it, it will print as 65. Okay. And there is something called as implicit casting. Right? We had seen a very small example of implicit casting, right? Or automatic assignment, right? We had seen a very simple example of implicit casting, or we can say automatic assignment. So automatic conversion. Let me show you here what happens. This is a very good example of automatic conversion. Here you have character A, but if you see its ASCII value, the ASCII value of this is about 97, right? And byte B can store the value 97. So 97 gets stored inside byte B, in this variable B. Similarly, this A, if you assign it to int I, this also gets stored what? 97. Obviously, it is in the range of integer. And check this out, what happens over here. Okay. See, here what we are doing is, here we have character 2 added to character 3. If you take character 2, that is basically value 50 and 3 is value 51 if you convert it into an integer. So 50 plus 51 happens and 101 gets allocated to this variable I. Okay. So you get to see the value is 101. Similarly, if you add something like this, so what happens here? Here A's value is 97. So this A gets converted into int 2 plus 97. That addition, that 99 goes to this J. Okay. So it will say J is 99. That's what it will print. Okay. Now if you want to use a Unicode character to be printed, now check this out. J's value is 99, right? So if you say you print it, J, what is J's value? Integer, right? So it will obviously print 99. But now if you say convert it to character by casting it into with this char keyword, then it will convert it into an Unicode character. Okay, it will convert it into an Unicode character, which is nothing but C. Obviously, if A is 97, then B is 98 and C is 99. Okay. Okay. And now one more thing is there. See, the output of all this is like this. Output of this I is 101, J is 99, 99 is the unique code for character C. And see here what happens. This is a string and this is a character. And string and character gets concatenated because we are using plus operator, which is nothing but concatenation operator, and thus you get to see this chapter 2. We can even use a number over here directly instead of single quote. If you use 2 as it is, then also it will get concatenated. Okay, so see what happens is whenever you are using this plus, okay, there is this plus, the smaller data type value gets converted into a bigger data type value. Remember this thing in Java. This is a smaller data type, character. Integer is a bigger data type. So the character gets converted into integer and then the addition happens. So the character's ASCII value was 97. So it got converted into number 97 and then it got added to 2 and then it was given to J. You see that? Similarly here the smaller data type is character and the bigger data type is string. So string and character becomes a string. You see that? Okay, so this is about casting between char and numeric types. Okay, so I think that's it for today. Let's call it the end of the day. Any doubts in this? Please let me know, guys. Any doubts? Yes?
No, sir, no doubt, sir.
Okay, Jayshankar, thank you. So I'll stop the recording. And if you have any issues, you can ask me. Okay.